electron affinity is the energy evolved or absorbed when an atom gains electron in its gaseous state. It is known as electron affinity. So it also works the same way with ionization energy. This is the shit I'm talking about. Electron affinity, EA. It also works in the same way with ionization energy. It increases the way ionization energy increases. It decreases the way it decreases. So the next thing is electronegativity. I don't want our time to be more than what we have actually promised ourselves. So electronegativity. That one is the ability of an atom to attract electron to itself in a compound. This is a compound containing hydrogen and oxygen, both of them together. So now it's a covalent compound, but in that covalent compound, one of them will have this strong will of taking more electron. Let's say now oxygen wants to take more electron. The ability of oxygen to take that electron, which they are not going to have the same value of electronegativity anymore, is the electronegativity of oxygen. That ability to take that electron towards its side to be negatively charged in that compound than the hydrogen. So I say again that the electronegativity is the ability of an element to attract electron towards itself in a compound. In a compound, that is a condition. It is different from electron affinity because of that. So also electronegativity increases across the period and decreases down the group. So what I mean by this arrow is that, so electronegativity is X, let's say X. So what I mean by this arrow is that it increases like this across the period and decreases down the group. So atomic size, atomic radius decreases across the period and increases down the group. So I don't know, I thought it would be a good way when I was trying to develop this way. But what is this way? I don't know if many of us know vectors here. Don't say resultant vector. I just try to take, this is the direction of this one. This is the direction of this one. The resultant vector is going to form like this. So this is the resultant vector. It is representing the direction of it. I beg. And I don't know if it turns to another over here. So please, let's take it this way. And this is the diagram. Please, let us try to note this thing. It's really going to help a lot. Just this one. Forget about all other things with it. Because the thing, maybe I'm confusing some people. I don't even know. And I thought I would be able to explain this thing. Mr. Vitros, please.
Yes, sir. Good evening. Yeah, I have a question about hydrogen, please. I don't know, you said hydrogen loses electron. I was like, I don't know if hydrogen have only one, and how is going to lose it? I was thinking maybe hydrogen is supposed to gain, not to lose.
Okay. So I said, if it is reacting with elements that are more higher than it in the reactivity series, like calcium, all those elements that are very, very reactive, sodium, it will be gaining electron. But when it comes to reacting with something like oxygen, hydrogen will be at the front. So hydrogen is moving that its own electron. It is releasing it out. And you know, it's something like this hydrogen atom. So it's going to leave this electron, lose it out. And oxygen too will now come and lose its own electron out. That's when they will now start sharing it. Losing electron, by that, I didn't mean that it will leave the electron, will not remain any electron. No. It will lose the electron out. Oxygen too will lose its own electron out. Both of them will now share it as paired electrons. So leaving a lone electron, and pairing the electron. This is covalent combination. Ordinary covalent combination. So that's what we mean. That's what I meant by saying this. It's not that hydrogen leaves the electron and it becomes zero. No. It's in the process of reacting with a highly electronegative element. In the case of nitrogen, oxygen, like forming hydrogen bond. Now, they say hydrogen bond is the dipole to dipole intermolecular force of attraction that exists between compounds formed when hydrogen reacts with highly electronegative elements like chlorine, oxygen, nitrogen, or fluorine, like the halogen, like that. So hydrogen will do as if it wants to donate the electron. The other elements too will do as if it wants to donate electron. The both of them are now going to donate the electron at the middle and they share it together. That's what I mean. It's not that it loses electron entirely. So, okay. Mr. Vitros. I'm still raising your hand.
Thank you, I understand. Sorry.
Miss Princess. Speak out, Miss Princess. Don't be carried away when you are raising your arm. You are just, it's like you're wasting our time here. Miss Princess. Okay. Opening configuration of ions. Thank you. Let's quickly go to that. So, everyone, this is a sodium atom. And this is a sodium ion. A sodium atom is different from a sodium ion. Sodium atom is ordinary sodium. Sodium ion is a sodium atom that has undergone chemical reaction. It has used an electron. What tells us that it has used an electron is because of the plus here. If it is Na2 plus, that means it loses 2 electrons. If it is Na3 plus, it means it loses 3 electrons. But it cannot be Na3 plus. If it is 2 plus, that's Ca2 plus. So now writing the electronic configuration of this thing, you know, sodium is 11. So you are going to write 1s2, 2s2, 2p6, 3s1, the 11, right? But sodium ion, that means it has lost 1 electron. So you are going to feel 10. Don't forget, instead of 11, it has become 10. So you are going to write 1s2, 2s2, 2p6. This is electronic configuration of sodium ion. Sodium ion. So this is a very good part to touch. Thank you. Or else everything we thought will just be waste. So this is another element. Chlorine atom has the atomic number of 17. So now the chlorine atom, let's write the electronic configuration. That's 1s2, 2s2, 2p6, 3s, 3p, okay, 3p5, I think. 17.
Yeah, you're right.
So now, after chlorine accepts 1 electron, it becomes chloride ion. Chloride ion. It's minus means it has accepted an electron. It is an anion. So it will now be 1s2. You know, it has accepted an electron. That means the electron has increased from 17 to 18. So we are filling 18 things now. 1s2, 2s2, 2p6, 3s2, 3p6. So you can see the difference between the both of them. The ionic radius is different from the what am I saying? The configuration of the ion is different from the configuration of the atom. This is the ordinary atom, and this is the ion. So now let's take an element with 3 electrons. So aluminium 3 plus. Aluminium has the atomic number of 13. So writing its configuration, let's write aluminium, ordinary aluminium first. 13. That's 1s2, 2s2, 2p6, 3s, 3p. If I'm right.
Yeah, you're right.
So now, after aluminium reacts, it has lost 3 electrons. This is aluminium ion, not aluminium atom. Aluminium ion, they are 2 different things. Ion. So it is a trivalent ion, and it is a cation because it is a positive ion. It loses electron. So I'm going to fill this thing now. It has lost 3 electrons out of 13. It remains 10. So let me fill it. 1s2, 2s2, and 2p6. This is a big difference between the both of them. It's those of you that are going to watch the video. Note these things. So it might be one of our questions. I don't know. Thank you for reminding me this, Mr. K. It's actually very useful because after teaching the electronic configuration now, someone should not go and say something like this. We didn't touch it. Oh my God, we disheartened. So God will help everyone. Any question before we round up? Any question from what we've been talking about since the beginning of the class? Any question? Any question? So take a good look at the table again. So this thing that I'm drawing here consists of electron affinity, ionization energy, and electronegativity. So for this one is only for atomic radius. Mr. Bemba.
Okay. I just have a question. But I want you to finish. The question is related to the electrical configuration of code. Following the alpha rules, if you follow it, I think it end is maybe 6x1.
What do you say? 6x1.
1. I don't get that. So I want to maybe you can shed light. After, if you still have time, if you don't have time, you can leave it.
Okay, good. We did good yesterday. I think you mentioned it. No problem. I will consider it. Mr. Ime. Where is your arm? Is he carried away? Mr. Ime.
Sorry, I'm not carried away because Mr. Bankolo was saying something. So, based on your explanation about electronegativity, can I say that now that magnet is an example of electronegativity?
What did you call it?
Possible. Magnet.
Electronegativity.
Yes.
It's not a charge electron.
No, my brother. No.
Wow.
Okay, please, can you repeat that explanation again? That will probably have the definition of electronegativity.
Okay, electronegativity is the ability of an atom to attract electron to itself when it is in a compound. This is oxygen and let me choose nitrogen in the same compound. Are you hearing me? This is the explanation. Oxygen and nitrogen in the same compound. So the both of them are electronegative elements. We all know that. So they will combine covalently where there is a uniform state attained. But this uniform state now, one of them still have a strong way of accepting more than the electron that it has before. You know when we say ojukokoro, one of them still has that ojukokoro. It has that strong will of accepting electron. But that electron is not that it's going to take it from outer place. It is still among the electron they are sharing. So it will now make it slightly more negative than this one. So its ability to take the electron it is wishing for, its ability to take the electron is known as electronegativity. So electronegativity is the ability of an element to attract electron to itself in compound.
All right, thank you.
My pleasure. Okay.
Yeah, just to go trace that, he needs to understand what a compound is. Compound is just when two or more elements are chemically combined together.
No, I'm quite sure. He knows that. I'm quite sure.
So I think that's what you should understand. So you cannot call magnet magnet cannot fall under electronegativity.
No, not at all. The elements that have properties of attracting magnet and the transition metals, not even all of them. So, okay, another question, please, Mr.
When you said magnet, I even thought you were saying manganese.
No, we are all learning here. It's not a big deal. It's not a big deal.
Sure,
I'm happy. I hope you have understood me. I hope. And if so, I'll be glad. Yeah, Mr. Bamikoli. I'm still using your app.
I'm here. Oh, no. Sorry.
Okay. Yeah, if that's the case, I think we're going to meet in the group. Everyone that we are here, we're about 24 or something here now. Okay. You know, we don't have much time again. Let's write the electronic configuration of a noble gas, everyone. A noble gas. I'm going to take argon. Argon, AR. That's the atomic number of 18. I'm going to write its electronic configuration now. It's going to stop in such there won't be space for another to enter that orbital unless you start from another energy level. That's it. In some electronic configuration, we have 3p1. But for argon, because it is a noble gas, it will be like 3p6. It will never exceed 3p6. So that's what will be. Let's write. Argon is 18. So 1s2, 2s2, 2p6, right? This is 10. 3s2, this is 12, and 3p6, this is 18. Yes, I already thought of using this too. Okay, I already thought of using this. Immediately you gave me that thing, I remembered I should use it. I may not measure it for yesterday or something. So I'm writing down that one, which is neon, atomic number of 10. That is 1s2, 2s2, 2p6, 10. I think that's all. 10. All. So now we want to use a method. Don't be confused if you see it in this way. Now we want to write the electronic configuration of calcium, which is 20. They now wrote argon, and after writing argon, they now wrote 4s2. Don't be confused. You know what argon represents? Argon represents all these things. This is electronic configuration of argon. The reason they are using it is that argon is a noble gas. It has all its shells completely filled. Argon, helium, neon, radium, xenon, krypton. They have their shells completely filled, so they can be used. It depends on how close they are to the elements. It's because argon is very close to these elements now. They are not writing all these things out. I want to write the electronic configuration of an element with atomic number of 7. That's nitrogen. I can just come here and write that of helium. Helium is 2 already. So I'll just write helium. That's 1s2. I'll now continue. 2s2. That becomes 4, right? And 2p3. So this is electronic configuration of nitrogen. Let me see if I'm going to buttress more. I don't understand. Please signify.
So it can be written like this if we too want to write ourselves.
Yes. Yeah. Okay. But if it's exam, I prefer you write it fully. If it's exam.
Sure.
So, but they will write it in this way for you. Many people will now be disturbed that how am I doing this thing? How take one more. Let's say I'm going to write the electronic configuration. Let's say I'm going to write the electronic configuration. Mr. Beluola or Mrs. Beluola, speak.
Okay. I come across something of such. This HE you wrote in the material, but sometimes you see HE, sometimes NE, BR, the one you wrote here, then KRXE. Like, how will the person, like, is there a way when you just write, okay, like now this one that you use, this atomic number of 20 that you used, you said AR4S2. So is there a way to solve it? Let's say we just say AR, then we are not giving this 4S2. Is there any way to arrive at it to get it? Instead of going through the long method of writing S, 1S2, 1S2, is there any short method that you can just use to get it?
The only short method is for you to just know that argon has the atomic number of 18. So you know the short method. Just know the atomic number of that element that they are putting inside that parenthesis. What's that? Argon has the atomic number of 18. So, and 4s2. So that 2 plus 18, that means they are writing the atomic configuration of calcium, electronic configuration of calcium. The only trick is to know the atomic number of that thing inside the bracket. This is helium now. To know the atomic number, to know this thing you wrote, is just to know the atomic number. It's not that you should be writing 1s2, don't bother. Just know its atomic number, 2 plus 2 plus 2. So that means, okay, plus 3. What we wrote here is for nitrogen 7. We are going to write iron. Someone is still raising his hand. Mr. Abulola, do you understand what I said now? Just use the number, the atomic number.
Yeah. What I'm okay, can I share my screen to show what I'm trying to say?
Let's see.
Okay.
Let's see. I think maybe you haven't gotten my explanation version.
Okay. Alright, so okay. Dark. This is what I'm trying to show. Like this plant.
You even have the material hardware, hard copy. You try it.
Yeah, it's very easy.
Okay.
So
this is
what I'm trying to say. So
touch one,
so
let
you
us
can
take
see.
it. Just
So
click on
and
one.
for the okay.
Choose one and I'll
So
explain
let's
it.
say for you see this part now they all have HE down. So it was this only this we can use to differentiate that okay, this is for the these they are symbols to
Yes.
identify it. So and for the next part too, you can see for here it's different. This is AR straight down, then KR.
Let me tell you the reason. It is that they are using the most or the closest, they are using the closest noble gas to that element they want to write. I want to write the electronic configuration of calcium now. I cannot go and use He now. Since there is another noble gas after He, which is argon before calcium. So I'll just use the argon. That's what they are doing. So they cannot write they cannot be wishing to write the electronic configuration of an element with an atomic number that is very high, and they'll be using that thing that's not close to it. So now they are using krypton here because krypton is the closest noble gas to the element they are writing. So to know the atomic number of what they did, or instead of writing 1s2, 1s out for that krypton, just to know the atomic number of that element, of that noble gas used.
All right. Okay, thank you. I really appreciate it.
No, pleasure, sir. I'm just not happy. You haven't got it. Let's take iron. Everyone, let's take. Well, I don't know. Atomic number of krypton. Okay, wait. Maybe 36. Yeah. Check it. Am I right? Right. Krypton. 36 now. I'm right. Check it, please.
Iron is 26.
No. Somebody wrote what is the atomic number of krypton now. Krypton. Is it the 36? I'm not sure. Okay, thank you. I'm right there.
Titanium.
Krypton. Don't worry, I've gotten the answer. We are doing iron of 26 here. So let us write it full first. I don't want to confuse anyone. So writing it full, we'll have 1s2, 2s2, 2p6, 3s2, 3p6. So jump a space, go and write 4s2. Now come and finish it. 3p what? I don't know. This is 10. This is another, so 3p6. This is what we've been doing since day yesterday. Everyone should know it.
3p6, not 3p6.
I wrote B. Thank you, Jerry. Thank you. That's a bad mistake. Thank you, Mr. Sticks. Thank you very, very, very much. Okay, so we've written it out now. We now want to take a good look at this thing. This is 10. This is 18. It is argon that has 18, right? Atomic number of 18. So all these things from this 1 to 18 now, let us use argon to represent it. Oh yeah. Argon. Oh yeah. 3d6, 4s2. This is what we are saying. Mr. Beluola, if you look at your book in the electronic configuration of iron, you see this is what they wrote out. Argon 3d6, 4s2.
Yeah, that's what's there.
So you can even you can write it this way, but don't make mistake. You can go and write it out first and try to know which one is the closest thing to it. So which one is the closest noble gas to it? This one is a noble gas. All the elements in group 18 are noble gases. Starting from helium, they are noble gases. That's what we mean. I think they end in xenon. So if it is that krypton you mentioned that we're writing now, let us say we are just writing krypton 36. So that means another element after krypton, we can use krypton to represent the thing before it and write the next one to finish it. That's what we'll do now. I will end our class. Odigi. Okay.
Yeah, Muchi.
Yeah, I'm just thinking the time here is already going out of it, but go for
10 o'clock. We'll finish it 10 o'clock. Let's.
Yeah. Krypton is 36. So 1s2, 2s2, 2p6, 3s2. Why am I the only one writing it? Someone should be telling me this thing. Time is long. We don't have time anymore. Don't worry. Make it
3p6.
Yeah.
3pc, 4s2.
3d.
Yeah.
4s2.
No. 3d.
I've written for it.
4s2 first. 3d.
You haven't understood this thing. You write 4s2 before 3d now.
Yes, then you were saying yesterday. Okay. That one is pertaining to transition method.
Mr. Babitole, ṣé mọ́mí ti dáná ṣá?
What it? No, more are confused because because according to the energy levels, low energy level has to be filled first.
Yeah.
4s has to be filled before 3d. Thank God you know it. Then why do you not say 3d?
The time we be about it dáná.
No. I know 4s has to be filled.
So after 4s to 3d.
Then when we were doing transition methods, you told us that the 3d has to come before 4s.
And you said we need to.
I'm only talking about writing. The same thing happened here. Only writing it. Before I wrote my 4s, I left a space. Your 3d must not appear behind 4s, beyond 4s.
Okay.
It must appear before the 4s. So I left a space. I went to go and fill 4s2 first, and now came back to fill the space with 3d then.
Okay.
And then cancel everything. This is krypton 36, 1s2, 2s2, 2p6, 3s2, 3p6. The next thing is 4s in the energy level. So look at my pen. I'm leaving that space first. Please fill 4s2 first. So now I'm going to fill 3d now. If it is not up to 10, then it will be like this. But now I still have up to 10. So I think this one is going to give me 20 something. 10, 20. Okay, this is even 30. So 4s2. After 4s2, it should be 4p6. 4p6. And this is it. So we've written the atomic number, electronic configuration of krypton now. Let us now take an element with the atomic number of 40. What could that be? From anyone, please. Element with the atomic number of 40. Anyone you kindly help us. Element with the atomic number of 40. Nobody. I will use to check here.
That's ZR. I don't know the
Zirconium.
ZR. So ZR for
Zirconium.
equals. So writing it, we have 1s2, 2s2. Okay, let's write it first that way. Let's write it that way first. So 40, that's equal to 1s2, 2s2, 2p6, 3s2, 3p6. So leave your space, write 4s2. Now come back to fill it. 3d there. I have 40 like this. It remains 10. After 4s2, it should be 4p6. This is 36. After 4p6, the next energy level is 5s.
Hello. Can you hear me? Okay.
I'm hearing you.
Okay. You are right. After Okay, yes, you are right. Continue. Thank you.
You know something? The only thing to help yourself, sir, is by practicing more. So you'll not be confused.
Yes.
So try to practice this thing often before the exam time. Don't worry, I'll tell Prodigy to help me arrest you now. My first will be he's a scout. So 4P6, after 4P6, I should have that's 5S, right?
Yeah.
Am I right? After 4S? 4P. 4S. So
Yeah,
5S. So 5S2. So now it is 40 that I'm supposed to pay. This is 5S2. It remains 1. How many? This is becoming 38 now. It remains just 2. So I'm now coming back to write 4D2.
Is it 1? Is it 2? Okay, 2, yeah.
Yeah, it's 2. So 4D2. So now, I know that when we wrote Krypton of 36, it ended here. So instead of writing the whole of this thing, Mr. Beluola, instead of writing 1S to 2S to 2 pieces, 3S to 3 pieces, 3D10, 4S to 4 pieces, I can only write KR for Krypton and come and finish it. 4D to 5S2. This is what we need in your text. So,
Yeah, that's what's done.
do you understand it now?
Yes, I understand.
That's what we need to do. Okay, because of this now, we're ending the class now. Thank you very much for your cooperation. And tomorrow, those of us that are computer science will be leaving the group for us to work with. So be leaving your past questions there, be leaving your questions there. You guys should have an section there. So be giving yourself questions to be answered. It's a very good way. You will surely remember an exam or when the question like that comes out. I'm quite sure of that. When a question like that comes out, you will surely remember. So because you've seen it in the group and you saw people replying to it, giving the answer, even yourself will be involved. So that will happen tomorrow, and that's the same thing that will be going on today now. Everyone, please kindly let us resume to the group. We'll still continue our class then. So that should be a class with evidence. I'm expecting to see your hand there, Mr. K, in the group. I've never seen you like maybe talk like I don't even know if you're in the group. Are you there? And listen, if are you there, Mr. K? It's not here. It did not.